This motherboard was supposed to be a straightforward job this week, something simple, a knocked off resistor, maybe a bias reflash, easy stuff, but no, not this time. The X570 Aorus Elite is actually a pretty common board on the repair bench. And this particular case, I think it deserves its own video. There's something interesting going on here, so I'd say stick around to the end. Let's get into it. Hey everyone, so today on the bench we have a Gigabyte X570 Aorus Elite gaming M4 board. No Wi-Fi on this one. Customer says it's completely dead, no reaction whatsoever, which honestly is not surprising. That's pretty much every other board that comes through here. So before we touch anything, first thing we do is just look carefully, no tools, no test yet, just eyes on the board. You'd be surprised how often you can spot something just like that without even pulling the heatsinks off. Usually it's around the PCI Express slot area where this GPU clips in, or on the back of the board. So those are the spots that take the most abuse during installation. Let's take a look. So the first what we would like to see is near the PCI Express slot. And I don't see anything critical over here. Doesn't look like that the components are damaged, but you see the signs here. Means that someone has tried to dismount the GPU within usually a screwdriver. This is our BIOS chip. I don't think it was desoldered. This is our, I guess, power controller. The area around the socket. And it looks clean. CPU socket. And it looks to me that all pins are good. Let's look at the back of the board. So let's see the CPU area over here. And it looks nice. This is probably SoC. This is the VRAM capacitors. The area under the PCH looks normal. There's no obvious damage. So let's try to power it on. But before that, we need to measure the resistances on the main power rails, just to be sure that we will not short our CPU. So this pin on the ground. Let's start with the 3.3 volts, and we have kilo ohms, 5 volts, kilo ohms as well, 5 VSB, and it's kind of low, 141 ohm. This is very concerning. 12 volts, kilo ohms, minus 12, no short. CPU 12 volts. We have kilo ohms here. Then we need to measure CPU to, let's say, V core right here. Mega ohms, V core itself, 55 ohms, normal. Then we can try to measure resistance on the coils. There's a couple of them. This one has kilo ohms here. Okay, almost a kilo ohm, no short, and mega ohms here, so no short as well. Okay, let's try to power it on to see if it reacts on the pressing the power button. Power on. Okay, it's way low, 22 milliamps for that board, and we're pressing the power button. And nothing happens. First, what we need to check if we have standby power. So let's see, this is probably 5 volt. We don't have anything here. Okay. This one. Okay, at least we have 5 volts. This is probably 5 VSB. Here. Okay, 5 volts here. So it looks like a P-channel MOSFET. And so if we have 5 volts here and here, so this is definitely should be a 0. Okay. So it looks healthy. So let's check what about the power button. So it looks like we don't have any voltage on the power button. This is definitely a problem that we don't have a power on the power button. So that means that we have a fault in some very early stage of power sequence. we need to check and measure the resistance. So we have less than 1 ohm. This is a dead short. I need to see the board view, but what I see right here on the Gigabyte boards, they have an ASD protection everywhere. This is usually a small 6-lax chips, which stands around the board and the main connection headers. This is probably the ESD protection, but I need to check. Okay, so I checked with the board view, and it looks like that the power button switch signal is connected to 3 elements. The first element is this ESD protection array, which is our suspect number 1. Another connection is SIO, which is right under this heatsink, and a BIOS Q flash chip. This is not the BIOS chip with the firmware, but the chip on top of this right here, which is responsible for the BIOS flash using the button on the back of the back plate. So what I would like to do firstly is to remove the heatsink from the PCH and SIO, just to be sure that there is no large hole in this SIO and nothing burned there. And then we will try to find what are the culprit of that shorted power button signal. Let's do it. So this is our SIO chip, and here we have IT8688E. The PCH looks normal. I guess what we need to do is to remove, to desolder this ESD chip, because it's just for the protection. So this is a power button right here. And yes, we have a short. Let's desolder this component. Okay, so we remove the chip. Now we need to find out if the short is gone or not. So the black probe to ground, and this probe right here. So let's see. We have 8.2 kilo ohms right now. So the short was gone, but the board still didn't post, which was not a surprise, honestly. When you have an overcurrent situation like that, it doesn't just stop at one component, everything on that line takes the hit. So I decided to move forward and inspect the other components on the adjacent lines. So I found another problem in the voltage regulator right near the SIO. If we will measure a resistance on this power regulator is basically has 5 volt right here, and it has a normal resistance. Well, almost normal. There's no dead short on this. That's an enable signal, and right here is an output. And our output is just 5.4 ohms, so it's almost dead short. We can try to power on the board and to see in the thermal camera. Maybe there is something heating up, and then we will find what is the problem. So this is our SIO chip right here. This is our regulator, and we will power it on right now. So pressing the power button. Okay, that's the regulator. Shiny as a bright star. So that basically confirmed that we have a problem with the regulator and not with the SIO, hopefully. But without this regulator, we will not have our motherboard started up. So what we need is to solder the same regulator from the donor board. See this red dot? That means it's dead, completely dead, and it's unrepairable. This is the same board, Gigabyte X570 Aorus Elite. After the components were replaced, the resistances recovered to their normal values, which means there was a good chance the board would finally react to the power button. But during the power on test, the board still refused to react to the power button, so I started looking into the SIO side. There should be 2.5 volts, and we have 1.5 volts. The pin number 65, which is the first pin on the bottom from the left side, should be 1.8 volts right here. And we have 3.3 volts. So we will definitely need to replace the SIO. Okay, let's power it on and to see if what we've done actually saved this board. So this is the moment. We'll need to show here we have a current consumption on. Okay, 167 milliamps, no change so far, but will it be turned on after I press the power button? And here we go. Yes, haha, finally. Okay, it could pause. So what I do is I just turn it off and I just plug in my HDMI here. Okay, this is good news already. And we need to put the heatsink right here, and just we need these pins. Okay, so power it on again, and we will see pause screen pressing the power button. Okay, here we go. I will keep holding this fan. Please paused. Okay, it's rebooted. This is good. Will we have a pause screen? Yes, we do. So the board is posted. Finally. Oh my god. There was SIO, power regulator, ESD array. It's unbelievable. Oh, you know what? Let's look what the BIOS is right here. And system info. 2019. Wow. This is way outdated. It's almost 7 years old. We will update it. There's definitely a bias of 2025, maybe 2026.
So we managed to bring this board back to life, and this was actually the 5th board this month with the faulty SIO, which I thought was worth mentioning. It was an interesting repair, and I'm really glad it worked out. If you enjoyed this video, please hit the like and subscribe button. It really helps the channel grow and keeps me motivated to record more of this. Thanks for watching, and I'll see you in the next one.